Good afternoon to everyone. Myself, Anand Kumar. I am going to talk about combination and sequential circuits. In that, we are going to see code converters. There are a lot of code converters are available for circuits. Here, we are going to discuss about binary to gray converters and gray to binary code converters. So, before going to start code converters, we must know about converting techniques because every machines are accepting the code based on their input signals only. The inputs are nothing but zeros and ones. The zeros and ones can be converted into the machines based on their own format. So there are a lot of code conversion techniques are there. So in that I am going to talk about binary to gray code converters. So the machines like computers or microprocessor or digital systems, they are performing their information. They are performing their task based on their input signals. The input signals are here given. We are given as a numbering systems, zeros and ones. Based on the numbering system, we can get the output signal and their information. So code converters. So initially they are given here as a 4-bit input signal. So 4-bit input is nothing but here in X signal it will act as an input signal and Y will be the output signal. Here we are given as a 4 input signal X1, X2, X3, X4 and the output will be a Y1 and Y2. Based on the input and output signal we can frame as a output as a circuit diagram. So the circuit diagram is prescribed by using XOR gates. The XOR gate is nothing but if the input signals are same, then the output will be a 0. If the input is different, then the output will be a 1. The same concept will be implemented for this XOR gate, and the upcoming slide also performing based on the input and logical expression of the circuit diagram. So here the output signal can be calculated by using this above XOR diagram. So here B3, B2, B0, B1 will be an input signal and the output is G3, G2, G1 and G0. Because we are performing here binary to gray code converting techniques, binary input signal as B0, B1 and B2, B3 and the gray output acted as a G0, G1, G2, G3. All the outputs are explained or get the information by using the K map only, because here we are going to perform binary to gray code techniques. So binary inputs, binary signals are given as an input. B0, B1, B2, B3 will be given as a input signals, and the output is G0, G1, G2, G3. The output will be get by K map. If the input signal is two input signal, then the K map, the box will be varied based on the input signals. So here we are performing 4 input signals, so that we are taking as 4 variable K map here. K is nothing but Karnaugh map. So based on the Karnaugh map only, we will get the output signal. The output can be matched by the circuit diagram, and the output, based on the output only, we will perform the circuit diagram. So first one is binary input signal. First binary signals, the B0, B1 and B2, B3 will be multiplied by both sides. So based on the multiplication, they are getting the information like output. The output is formed by multiplication of both input signal. There may be some properties are there. Based on the properties, the output will be defined. The output will be formed by using the above K map variable. And next one is the circuit diagram having the output B0, B1, B2, B3. Based on the output signal, the circuit diagram has been framed. B0, B1, because we are using XOR gate here. XOR is nothing but if the input is varied 0 or 1 means, then the output will be a 1. If the input is same, then the output will be a 0. The based on the concept only, the truth table and the logic table will be framed. So in this case, binary to gray code, binary signals as input signals for 4 variable K map. So there are 16 input signals will be given, and based on the input, the output will be formed by using XOR gate. So initially the table was framed by XOR gate. First one is first gate. First option is first number, first system will be as a same one. First input has taken as a same in the output. Then the next output will be taken from the next input signal. For example, if the first input is 1 means, then the output will be framed as the same one. Then the next signal can be multiplied by previous signal. 1 into 1, 1 into 1, the same signal means 0. Next one is 1 into 0 means the output will be 1. 0 into 1 means then the output will be 1. Like that, the same operation will be executed until the last input signal. So here, the next we are going to see about gray to binary code. So far we have discussed about binary to gray code operations. And next one is gray to binary code operation. The change is reverse operation. The same concept, the same operation will be executed, but the thing is the input may be changed the way the same operation in a reverse manner. All the KMF variables has been assigned based on the reverse operation, and then the output will be taken as a gray code binary. The output will be taken as a binary one. The input is a gray code. Gray code will be input signal, and the output will be as binary one. So based on the XOR gate operation, like a previous case, then the output will be framed. Then the output will be taken as a XOR gate operation. Thank you.